All right, guys, so this is the second part of the notes for section 6.2. We are continuing to talk about multiplying and dividing rational functions. In the first part of this section, in the first video, we obviously talked about multiplying. We're now going to see how dividing is very closely related to multiplying. Before we define dividing rational expressions and how to do that, as a warm-up, let's just think about how we would divide two fractions. So if we were asked to divide 22 over 25 by 14/10, then if you go back, and this is going back to probably late elementary school, maybe early middle school that you would have done this. But what you would have done is you would have kept the first fraction the same. You would have changed your division to multiplication, and then you would have taken the reciprocal or flipped your second fraction. You might have had kind of maybe a little cheesy, kind of corny way to remember this. Keep, change, flip, or keep, flip, change, depending on who your teacher was and how they chose to say it. But the more kind of mathematical way and the way that we should probably say what we're doing in an honors algebra 2 class is that to divide rational expressions, and in fact to divide any sort of fraction, we are going to multiply by the reciprocal. So multiply by the reciprocal. And basically what we're saying is that we're multiplying by the second fraction, and we've flipped that second fraction. And so in this case, what we would end up doing then is simplifying as much as we can. So just like we did on previous problems, 10 and 25 are both divisible by 5. 10 divided by 5 is 2. 25 divided by 5 is 5. And then we could go ahead and simplify some other stuff as well. 22 and 14 are both divisible by 2. 22 divided by 2 is 11. 14 divided by 2 is 7. And then once we've simplified as much as possible, remember you just multiply straight across. So 11 multiplied by 2 is 22. 5 multiplied by 7 is 35. So our answer for this particular problem would be 22 over 35. Now obviously with fractions, that's pretty easy once you kind of remember that rule. And it turns out for rational functions, it's really no different. The only thing that we'll kind of have to do is be careful with our domain restrictions. But really, other than that, we're not going to have a whole lot else to worry about. Really, once you've done that first step of flipping your second fraction, it just becomes a matter of multiplication, which we've already done. So let's take a look at some examples where we've got some rational expressions that we are simplifying. So in order to do that, let's take a look first at example A. We are going to look at 6 over x cubed divided by 12 over x to the 5th. And as we're looking at this, we actually want to always start with domain restrictions, because once we flip our second fraction, our denominator is going to then be different. So that's going to be kind of the step that we'll have to be careful of as we're working through this. And so looking at our current expressions, the only variable in our denominator, the only factor is x. And so we wouldn't want for x to be 0. So we'll just state that as our domain restriction for right now, which is that x cannot equal 0. So then to divide these two rational expressions, we're going to follow the same rules that we did with our fractions. We're going to keep our first fraction the same, change our sign to multiplication, and then take the reciprocal and flip our second fraction, so that now we have 6 over x cubed multiplied by x to the 5th over 12. So now it just becomes multiplication like we've done before. So let's do some simplifying. We've got 6 and 12, which are both divisible by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. As for our variables, we've got x to the 3rd and x to the 5th. All of these x to the 3rds will cancel with 3 of these x to the 5th, so that will become x squared. And now we should be ready to go ahead and multiply straight across. For our numerator, we have 1x squared, so that's just x squared. For our denominator, we just have 2, so that would become x squared over 2. Now, in our final answer, we no longer had x in our denominator, so we would need to state this as a domain restriction on Big Ideas Math and say that x cannot equal 0, because obviously that's no longer apparent in our final answer. let's take a look at another example. So let's take a look at example B here. Now, first thing you're going to want to do is you're going to want to factor if it's not already. Now, the first expression is already factored for us, x minus 4 over x minus 2 squared. But for our second fraction, let's go ahead and do some factoring. Starting with our numerator, it's got 3 terms and no greatest common factor. So let's find some numbers that multiply to be negative 4 and add to be negative 3, which would be negative 4 and positive 1. As for our denominator, we do have a difference of squares. So that will be pretty easy, just x plus 2 and x minus 2. Once we've factored, let's go ahead and state our domain restrictions. So looking at our denominator, we've got x minus 2 squared. So obviously x can equal 2. For the next factor, x plus 2, we'll have that x cannot equal negative 2. And then for the last factor, x minus 2, we've already said that x can equal 2, so we're good there. All right, so let's go ahead and do our division now. So we'll start by keeping our first fraction unchanged, so x minus 4 over the quantity x minus 2 squared. We'll change our division to multiplication, and we'll go ahead and take the reciprocal. So x plus 2 and x minus 2 are now in the numerator, whereas x minus 4 and x plus 1 are in our denominator. So now, we're just going to do our multiplication like normal. Let's see which factors we can cancel. Obviously, x minus 4 can cancel out with the x minus 4 in our denominator. We also have an x minus 2 in our numerator, which can cancel with one of the x minus 2's in our denominator. At this point, there's nothing else that we can do, so let's go ahead and write our simplified expression. We've got x plus 2 as the only factor in our numerator. For our denominator, we've got the factors x minus 2 and x plus 1. So now we actually have an additional domain restriction that we need to consider, which is that x cannot equal negative 1 now, because now we have negative 1 in our denominator, so we need to be careful with that. Now also notice that x minus 2 is still there. The factor, though, that we can no longer see is x plus 2, which is now in our numerator. So this x cannot equal negative 2 is the domain restriction that we would need to use on Big Ideas Math. Okay, let's do a few more examples. For example C, we once again just have our expressions with our numbers and variables. We don't have any factoring that needs to happen. Let's go ahead and start by just stating the domain restriction that we have from the very beginning, which is that x cannot equal 0 because of our first fraction having x in our denominator. But now we can go straight to our multiplication. So we'll change our division symbol to multiplication and change our second fraction to the reciprocal. So now we can start to simplify. We can start with maybe the 12 and this 3, which are both divisible by 3. 12 divided by 3 is 4, and 3 divided by 3 is 1, so it's gone. Next, for 7 and 35, both of those are divisible by 7. 7 divided by 7 is 1, so we can get rid of that completely. And 35 divided by 7 is 5. Next, let's take a look at x. Probably the easiest way to work with x would be to cancel out x squared and x squared, and then x to the 5th we don't have to worry about. Finally, for y, we've got y to the first power over y squared. So our 1y in our numerator will cancel one of our y's from our denominator, and that'll leave us with y to the first. So now you got to be very careful with what we've got left over. Let's see what we've got as part of our final answer. For our numerator, it looks like the only thing we were left with was a positive 4. For our denominator, we've got 5, x to the 5th, and y to the 1st. So that would be 5x to the 5th multiplied by y. And again, since it's the first power, we really don't need to write that. And here's our final answer. Now, as far as domain restrictions, that does give us another restriction. Now, y cannot equal 0 since it's in our denominator. But since both x and y are still visible in our final answer, we actually would not need to type any of those domain restrictions on Big Ideas Math. All right, let's take a look at example D. And as you can tell, lots of factoring that's going to have to happen on example D. So let's start by factoring everything. To begin with, let's look at our first numerator, x to the fourth minus 4x squared, where our greatest common factor is x squared. When we factor that out, we'll get x squared minus 4 inside of our parentheses. So then, as we continue to look to factor, what's left inside that parentheses is a difference of squares, so we can rewrite that to be x plus 2 and x minus 2. Now let's go ahead and take a look at our denominator for our first fraction, where we've got x squared minus 9. That is a difference of squares, so that would be x plus 3 and x minus 3. Next, let's take a look at our numerator for our second fraction, where our greatest common factor is x squared. When we factor that out, we'll have x squared minus 4x plus 4 inside of our parentheses. Looking to continue factoring, we're looking for numbers that multiply to be 4, that add to be negative 4. The two numbers that will work are going to be x minus 2 and x minus 2, because negative 2 multiplied by negative 2 is positive 4, and negative 2 plus negative 2 is negative 4. Finally, we just have our denominator to factor. We're looking for numbers that multiply to be 9, that add to be negative 6. Those two numbers are going to be negative 3 and negative 3. Now there's a lot going on, so let me do this. Let me just rewrite what we've got as far as our original expression in factored form. So our first numerator was factored to be x squared and then x plus 2 and x minus 2, whereas the denominator was just x plus 3 and x minus 3. Now we still have division. I haven't changed anything yet. And let's go ahead and write down what our second fraction was in factored form, which is x squared, x minus 2, multiplied by itself, x minus 2, all over x minus 3, multiplied by itself, x minus 3. So now, before we do anything else, let's go ahead and write down what our domain restriction is, which now should be a little bit more clear. For our first factor, x plus 3, we know that x cannot equal negative 3. And for our second factor, which actually is the same factor for the next two as well, we would know that x cannot equal positive 3 as well. All right, so now let's go ahead and do our multiplication. So we're going to keep our first fraction the same. So x squared, x plus 2, x minus 2, over x plus 3, x minus 3. And then we'll go ahead and change our sign to be multiplication. And we'll go ahead and write the reciprocal for our second fraction. So that would be x minus 3 over x minus 3, and then x squared over x minus 2 multiplied by x minus 2. Okay, so let's go through some simplifying. X squared is going to cancel out completely with x squared. We've got x minus 2, which will cancel with one of the x minus 2's. And then we'll have x minus 3, which will cancel with x minus 3. So now, looking at our simplified expression, let's see what we've got for our numerator. We still have x plus 2 and x minus 3. For our denominator, we have x plus 3 and x minus 2, which notice is as simplified as we can make it. It's got a lot of the same numbers, but they're not exactly the same. We've got pluses and minuses that don't match up. So it turns out this is going to be our simplified expression, which does give us one additional domain restriction. Looking at our denominator, x minus 2, we now have to say that x cannot equal positive 2. And one of our factors is no longer there. We can no longer see the factor of x minus 3, which means this restriction of x cannot equal 3 is the one that we would need to use on Big Ideas Math. All right, I think we've got about 3 more examples that we are going to take a look at. So let's take a look at example E, which will give us a chance to talk about what to do if there's multiple operations in a single problem. So we've got our first fraction divided by the second fraction, but then multiplied by our third fraction. Now, before we actually do anything else, let's just go ahead and factor anywhere we can. So in our first fraction, our denominator has a GCF of 3, so if we factor that out, we'll have x squared minus 4 in the parentheses. And then we can continue to factor that because it's a difference of squares, to be x plus 2, x minus 2. For our second fraction, if we take a look at the numerator, we do have a greatest common factor of x squared, which will leave us with x plus 5 inside the parentheses, and that's as much factoring as we can do. In our denominator, though, with x squared plus 3x minus 10, we would look for numbers that multiply to be negative 10, that add to be positive 3. Those two numbers are going to be x plus 5 and x minus 2. Once again, I'm just going to copy everything down before we try to do any operations, just to make it a little bit more clear what we are now working with. So for our first fraction, we've got x cubed over 3 multiplied by x plus 2 multiplied by x minus 2. That's being divided by x squared over x plus 5, or x squared multiplied by x plus 5, over x plus 5 multiplied by x minus 2. And then we also have a multiplication at the end of the problem, which is multiplying by 6 over x. Now, before we get to any of the operations, let's go ahead and state our domain restrictions as of right now. For our first factor, x plus 2, we would have to say that x cannot equal negative 2. For the second factor, x minus 2, we now cannot have x equal positive 2. For the third factor, x plus 5, we'll have to say that x cannot equal negative 5. For the next factor, x minus 2, we already have our domain restriction for that factor. And finally, for x by itself, we'll have to say that x cannot equal 0. All right, so now let's get into the operations that we are going to have to do. So we're going to keep our first fraction the same. We're going to change division to be multiplication by taking the reciprocal of only our second fraction. The third fraction, which is 6 over x, is going to remain as 6 over x. So when you are working with multiple operations and one of them is division, you only flip or take the reciprocal of whichever fraction you're dividing by. If there's multiplication later on, just leave that as it is. All right, so let's get to some simplifying. Let's start maybe with x to the third and this x squared. X squared can be canceled out completely because we will take away 2 x's from x to the third, which now makes it x to the first. But now continuing to look at that x, we do have another x. It's just way off to the side, but it is also in our denominator. So x to the first and x are going to cancel out completely. Next, we've got our factor of x plus 5, which will cancel out completely. And then also x minus 2, which will cancel out completely as well. Now, we also have some numbers. Notice that we have both 6 and 3, which are divisible by 3. 6 divided by 3 is 2, and 3 divided by 3 is 1, so that will also cancel out completely. So let's see what we've got left. After all of that in our numerator, the only thing we have left is a 2, and for our denominator, the only thing we have left is an x plus 2. So the only domain restriction that we can still see in our numerator is that x cannot equal negative 2. The other domain restrictions of 2, negative 5, and 0 are no longer visible. Those are going to be the ones that we need to use on Big Ideas Math. Now, as you may recall, division can also take the form of a fraction. In other words, if I wanted to write 5 divided by 2, another way I could do that would be to write it as a fraction as 5 over 2. That's going to be the idea behind these next two examples, is that we are still going to be doing division, but it's written a little bit different. Now we've got it written as a fraction. So we've got fractions inside of fractions now. A little bit crazy to think about. Let's go ahead and rewrite it as division to make it a little bit more comfortable, maybe a little bit more familiar. So to do that, the top of our large fraction, the numerator, which is x plus 2 over x minus 3, comes first. And then where this large division bar is, large fraction bar I should say, is going to become a division symbol. And then what's underneath of that fraction is going to become a fraction itself, so x plus 1 over x minus 3. Now let's go ahead and write our domain restriction for right now. That's just that x cannot equal positive 3. That's the only factor in our denominator. And actually we should be ready to go ahead and multiply. So let's go ahead and keep our first fraction the same, change our sign to be multiplication, and then we'll take our reciprocal for our second fraction, so x minus 3 over x plus 1. At which point there is going to be a factor which will cancel, which is x minus 3. That leaves us with a final answer of x plus 2 over x plus 1. So in addition to our domain restriction that we had, we now have a new domain restriction as well. Since x plus 1 is now in our denominator, we now have to say that x cannot equal negative 1. Now there was a factor which canceled out completely. X cannot equal 3 is no longer visible as part of our final answer, so that would be the factor that you would use on Big Ideas Math. All right, let's take a look at one last example. Again, this is going to kind of use that same idea from the previous example where we're looking at a very large fraction where it is one fraction divided by another. So we've got the numerator for our fraction, which is 2x minus 6 over x squared plus 9x plus 20, and our denominator, which is x squared minus 9 over x squared plus 5x plus 4. Let's first just rewrite this as a division problem. So in order to do that, we'll first copy down our numerator as its own fraction. So 2x minus 6 over x squared plus 9x plus 20. And then where the large fraction bar is, we'll go ahead and change that to be a division symbol. And then we'll go ahead and copy down our denominator as its own fraction. So x squared minus 9 over x squared plus 5x plus 4. At this point, we're going to go ahead and do some factoring. So for our numerator for our first fraction, we do have a greatest common factor, which is 2. When we factor that out, we'll have x minus 3 still inside the parentheses. For the denominator of our first fraction, we'd be looking for numbers that multiply to be 20, which add to be 9. Those two numbers are 4 and 5. As for our second fraction, in the numerator, x squared minus 9 is a difference of squares, so that would be x plus 3 and x minus 3. For our denominator, we'd look for numbers that multiply to be 4 and add to be 5, which are positive 4 and positive 1. So let's do this. Again, after I've factored, I like to rewrite everything in factored form just to make it a little bit easier to work with. So our first fraction in factored form was 2 parentheses x minus 3 over x plus 4, x plus 5, divided by our second fraction, x plus 3, x minus 3, over x plus 4, x plus 1. Now, before we do anything else, let's go ahead and state our domain restriction now that we've got everything in factored form. For our first factor, x plus 4, we would have to say x cannot equal negative 4. For our second factor, x plus 5, we'll have to say x cannot equal negative 5. For the third factor, x plus 4, we've already taken care of. And finally, for x plus 1, we'll have to say that x cannot equal negative 1. All right, so now let's go ahead and do our operation. So we'll keep our first fraction the same. And then we'll change our division symbol to being multiplication. And then go ahead and write the reciprocal for our second fraction. And now we should be ready to go ahead and start simplifying. So to begin with, we've got the factor of x minus 3, which will factor with our other factor of x minus 3. We also have x plus 4, which will factor with our x plus 4 in our denominator. And actually, at that point, I'm looking, and I think that's about it. So left in our numerator was the 2 and our factor of x plus 1. In our denominator, our factors of x plus 5 and x plus 3. Which does give us an additional domain restriction. Since x plus 3 is now in our denominator, we'll have to say that x cannot equal negative 3. There were actually 2 factors which are no longer visible in our denominator, which are the x cannot equal negative 1 and the domain restriction for x cannot equal negative 4. So those 2 are the 2 that you would need to make sure you included on Big Ideas Math. All right, guys, that does it for division. As you can see, really, besides that first step of multiplying by the reciprocal, everything is the exact same as multiplication, and that is our first two operations under our belt. Okay, so in the next video, as you can see, we're going to be taking a look at addition and subtraction. We will probably also separate that section into a couple of videos, so just be prepared for that. Until next time, guys, have a great rest of your day.